ahead, connect to the server. You've already done that. And you've drawn out the, bing, there it is. We're doing the one today, the one that says proof. And where did it go? Here we go. There's classes folder. So we're doing this one today. Proof. Make a copy of it. Now you can disconnect from the server, but you're going to need it later on for sending. You know, I'm going to disconnect right now. Go ahead and put your name on it. Remember, you want to own it. And you open it up and it looks like that. And you can go ahead and put your name on the inside as well. If your name was Fred, you could write that. So we are going to do a proof of the Pythagorean theorem, not the only one. There are many proofs. Now we're going to do an old one. And honestly, I don't know if this is attributed to the Chinese or the Indian mathematicians, but it is a very, very old proof. So let's get on it. If you grab this point, you're going to notice, see, I made a segment for you. You can change the size of the segment, and you can change this point here. You can change the distance A and B.
Why does that segment not look straight?
Well, it must be your eyes, because it's, you know, I mean, all segments. This segment is straight, and whether do you mean horizontal or do you mean straight?
No, it looks curved.
It looks like it's bent. Well, it's probably some waviness in this. But I can assure you that it is that these 3 points are collinear. All right. Okay. First off, I didn't say that. I just want you to experiment, just to demonstrate to yourself that you can change this, right? And you can change this. That's the key for your drawing. We're going to first off, we're going to construct the drawing, and then we're going to execute the proof. So. And we're trying to record this one today, so you may be able to play it back on anybody else who misses. So we're going to start by doing this. Double click on the point W. Light it up as your center of rotation. And now I'm going to sweep and select this, right? So you've got the two segments, the red and the blue, and you've got these two endpoints. Notice I don't need the one on the far left. Transformers, rotate by 90 degrees. So right now you've got something that looks like this. And go ahead and put in the right angle symbol. Remember, click 1, 2, 3. We programmed it that way, so it's vertex, red, blue. Always goes counterclockwise. And now we're going to label some tools. Grab your label tool. And when I click on this red, notice it's going to come up A prime. When I click on the blue, it's going to come up B prime. And, you know, it'll be more fun if we make this pretty. So I'm going to get rid of that prime because A is really referring to the length of that segment. And it's the same length as the other red segment. So I'm going to change it to A, and I'm going to color it red. I'm going to change this one to B, and B for bleu. So I'm going to color that blue. Remember, you use this box up here, the text palette, to change the color of text. Now, you might think I'm going fast for a little bit, but you guys are all good at this. And I will loop back and come around, walk around the room and see after we get this drawing underway. How many of you have this? Raise your hand if you have this. Raise your hand if you do not have this. If you do, no, only if you do not have this. No, I only said change the A prime to A. Oh my God. Center rotation. All right, we all good? Let's move on. Now, we are going to select these points again. I'm going to select this endpoint. I could say both of the blue endpoints, the blue segment and the red segment. Transformers, and you're going to rotate again by 90 degrees. It's a box. So I'm going to put in my right angle sign there. Click, click, click.
You had to highlight that one.
All right. To use the custom tool, you must select the custom tool. Correct. Well, yes, you got to highlight the thing you want to rotate. And then finally, I'm going to finish this figure by rotating these. Whoa, 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 whoa. Missed. Rotate. And there you go. Now, I want you to go through and label all the pieces. I'm going to label that B because it's the length B. And the red ones we're going to make A. And we're going to color them red so that we can give instruction faster. So right now, you've got a figure that looks like this. If you move, you've got these sides change. Yeah, that's kind of cool. Oh, there's more to it than that. Put in your right angles. Put in your right angles like that. Click on the vertex, red, then blue. Now, the overall figure, that entire figure is a what? It's a square. We know that because it's got 4 right angles and all the sides are the same. And now for you engineers, who's in the engineering? Raise your hand for your engineering. Okay, engineering, I want you to go to the custom tool, pull down to dimension line. Now, this is I wrote this one, so it's unlike AutoCAD. You know, kind of like AutoCAD, but you got to snap it from there to there. But unlike AutoCAD, it's not going to measure for you. So now, and then I want you to snap it from there to there. You're going to need this later on. And this is just a nice way to say, when I click on this, it's going to come up something, some random letter. Let's double click on that and say, replace it with an expression. How long is the side of the square? A plus B, that's correct. A, so just make it A plus B. And I'll make it some neutral color like black. Whoa, we're going to use magenta later on. Oh, yeah. Well, magenta's okay. So, well, we're not naming it. We're really, see, remember, we're adding, in each case, the red segment plus the blue segment. That's A plus B. Right? You all see that? So this square has dimensions red plus blue, or A plus B. Now, the next thing we're going to do is we're going to draw some segments. Snap, snap. But I'm going to make that line green. Make it thick. So go ahead and draw these lines in there. They're not random. You're connecting the points between A and B. Now, no, it looks yellow on, remember, I said green. They look yellow up on my screen. On your screen, they're going to be green. And I want you to label it C. You pick. So all of these, I'm going to label them C. Pretty cool, huh? Well, and then before I walk around the room and check that where you are, I want you to shade one of the 4 triangles. Construct triangle interior and pick a color that's, you know, it's kind of light, but not green. We're going to save that for something else. Okay. Come around and see how you're doing. Click on the 3 vertices and then go to construct triangle interior. Click on the 3 vertices, construct triangle interior. So you're just going to shade any one of the 4 triangles. Well, you can go in any direction and you'll get them. Other polygons it will matter, but a triangle does not. So click on the three vertices of any one of your triangles. You pick a color, but not a dark one. It's got to be something you can see through. It can be magenta, our favorite color. So now, no, not the square, the triangle. The triangle, not the square. All right, raise your hand if you got the triangle. All right, I'm looking around. I'm seeing success. Catherine, you got it? Okay. So now, remember, we already identified W as my center of rotation, your center of rotation. Select the interior of your triangle. Select your triangle interior. Transformers, rotate. The default is 90 degrees. And where does it go?
To the other side.
It fills that triangle in. Well, wait a minute. Whoa. That's the very concept. If two polygons are an exact match, one fits over the other, that's the very concept that we know as congruence. That's what we said was congruence. So we're demonstrating congruence, but we'll prove it too. So go ahead and rotate it again. Transformers, rotate. Wah! Oh yeah, rotate it again. Now I'm going to move some of this stuff, my titles, out of the way because I need the space. You guys have a bigger screen. So now, hey guys, come on. We're starting our logical argument. And again, we're not doing two-column form. We're going to try to do this. This is a bit of a paragraph, but we got to get all the necessary steps. And I'm going to say the four right triangles are congruent by, why are they congruent? Well, actually, you could say that. You could say side angle side. Actually, I suppose you could say HL2, or you could say side, side, side. But I want to stick with side, side, side because, of course, we started with an A and a B and a C. You know, I guess it might be better. Actually, let's go with SAS. I like that better because we started making those things perpendicular, and yeah, that's better. We made right angles with a 90-degree rotation, and the A's and B's are all congruent. So let's go with side angle side. Now, if those triangles are all congruent, it's time to draw something. I want to grab the orange angle tool, and I want you to do this. Watch where I go. Click, vertex, blue to green. Click, blue to green. Click, blue to green. Click, blue. Now, if you're having trouble, don't worry, you'll get that caught up. You'll figure that out. We've done this before. And I'm going to write down, it's just the beauty of color, we can use it in our proof. We'll say all four orange angles not or angles. All four orange angles are congruent by, all right, what would Aretha Franklin say? What's this? How does that song go? Why are the triangles congruent? All right. CPCTC, all right. CPCTC. All those orange angles are congruent by CPCTC. Now, I made another tool for you, and it's, of course, magenta. So go ahead, color in the magenta angles. Vertex, green, snap to red. Vertex, green, snap to red. Snap at the vertex, the green, and the red. Hey, look at that. Now, I'm gonna cheat a little bit because I'm a lazy typist. Remember, anytime you want to copy, if I take the select tool, I select this, I hit Command C, and then I click off, I hit Command V, it makes a copy. Now, if that's true for the orange angles, it's true for the magenta angles. Love using color. Command C copies, and then Command V is paste. We're going to do that a lot because when we actually get to the algebra in this proof. Now, if you've gotten this far, you can hide the W. We don't need it anymore. And it makes it, yeah, bye-bye, W. It actually looked kind of ugly anyway. So we just needed that for construction. It's kind of fun. And you see what's going to happen. We can move it around like this. Woo, grasshopper. Oh, yeah. Now hang on. We're going to come up with something else here. Now, I hate to do this, but I'm going to try to number some of these angles. We're only going to look at a couple angles down here. All right? Now, I want to click on this one. I'm going to call this one angle 1. And I'm going to call this one angle 2. I'm numbering 2 of our many angles. One magenta and one orange. Because we're going to write an argument about these. I guess I'm getting ahead of myself. Well, hang on to that. You do need to number them, but you'll come back to that. I don't care what color. Just make them stand out. I forgot to say one line. We have to write another line in here. Now, in our diagram, remember, we only have 3 different angles in our diagram. The right angles, the magenta angles, and the orange angles, and we could change the size. But I'm going to say something. Well, actually, let me look over here. Look at this. See this triangle? Guys, eyes up to the front. See this triangle? Something we do know. Remember, the sum of the interior angles of a triangle add up to 180. Now, the corollary to that says when it's a right triangle, the 2 acute angles have to add up to 90. So for that reason, we're going to say the magenta and orange angles are complementary. They're complementary, and we'll say, if you want to write it down, say by corollary to triangle sum theorem. Now remember, triangle sum theorem, back in our book, that was theorem 4.1. Not that we care about that stuff, but the corollary said that in a right triangle, the angles are complementary. So that means that angle 1 plus angle 2, see, one of those is magenta and one of those is orange. So watch what I'm going to say here. Therefore, angle 3, see, I didn't even number it yet, is a right angle. Now, you say, where's angle 3, Mr. Banish? And I'm going to show you. I'm going to snap it right in here. Snap, snap, snap. Now, why is that? Because angle 1 and 2 are complementary, and they all add up to 180, because we got collinearity, and I'm just going to snap on that. I'm going to call that angle 3. Yeah, well, that's a fancy angle. Orange angles. Thank you. All right, as far as the trick, if you want to make it neat so the numbers move with the drawing, you actually got to snap them to a piece of, so like snap a label onto that on the little segment and change it to a number. Now, honestly, if you don't do that and you just put a piece of dumb text so it doesn't move around, that's all right too. But you want it to be pretty. Why? Because it's cool if it's pretty. Look at that. Heavens to Murgatroyds, we're getting some great construction here. Now, I could say this argument, I could repeat this argument here all the way around the figure. So go ahead and put in the other right angles. Angle 3 is the right angle, yes, because the three angles have to add up to 180 because they form a straight angle. Now, when you've got that, I'm going to now shade this quadrilateral in the middle. I'm going to go click, 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 construct quadrilateral interior. And you can make it any color as long as it's green. There you go. Which looks yellow to you. But there you go. Make it green just so we can use color to demonstrate. Now, the green figure is now a what? Square, because it's got 4 right angles and it's got 4 congruent sides. Now we had to prove that. And now we have the groundwork has been set for the algebra. We're pretty much there. So we might just walk around, make sure you got this. Notice if you move it around, you get this. Isn't that cool? Wow. Ooh, grasshopper. Now, I know some people want to animate their drawings. I'm not in, if you must animate it, please don't make the thing dance around. It's distracting. Select only one of these points. Edit, action. Go to animation. Make it go slow so it's not distracting. And there you go if you want to animate the point. And that kind of demonstrates that it works for any lengths A and B. All right, so while you're doing that, I want to walk around really quickly and then we got to get crack-a-lacking. Isn't that actually kind of cool? All right. Now, this is beautiful. Beautiful. So again, don't sweat I'm not really caring about about the actual animation or anything. That's just for fun. Oh. Okay, next. Come on, we got to get through this so Cody can get to his other thing. All right. Well, I'll leave mine running. Okay, everyone, we've laid the ground rules. We're ready to move on. I might shrink that up. It's taking up too much room. So that's our argument so far. We've got the diagram, and we've concluded that the green thing's a square. Now I'm going to shrink my figure there, so I need some room to write. You don't need to shrink it unless all your room's gone. Don't animate. Don't waste time. You do that when we're done. Let's do the math part. Now, I want you to write this down because this is the entire concept that makes this work. We're going to say that the area, actually let's write it in Word. I'm going to use smaller font so we can write just in sentences. We're going to say that the area of the big square is equal to the area of the four triangles plus the area of the green or smaller square. Pretty cool, huh? Now, first off, on this whole proof, we have to accept that that's true. Now, I know some of you might, if you're put tiling in your bathroom, you'd say, well, I don't know. What about the grout? Well, this is in theory, and I'm just telling you, this is a theorem that we are going to come to know and love back in, I think, up in chapter 11 on area. So we're going to use it now, though. So in other words, we're going to say that a composite figure is the sum of its pieces, non-overlapping. Y'all good with that? Everybody see that? Now, I wrote it in words there, and we're going to translate words into math. Now, the big square is, well, of course, we got the big square, the overall square. What are the length of the sides of the big square? A plus B. That's correct. So now, let's make sure we get this right. And there's a lot of funny characters, so, there's subscripts, superscripts, and all that stuff. So let's be careful with this. I'm going to use right there, I'm going to say A plus B. And I am going to surround it like this, and I'm going to the exponent, because I am going to square the entire expression. That's a binomial, A plus B. Now, if you get stuck on the logistics of doing this, you can please help each other, and I'll be glad to help you, but let's get through the logic. If you are up here in the exponent, and you want to get back down to your writing normal, hit the right arrow. The right arrow drops you back down. So, that's the area of the big square. It's equal to the four triangles, but we said the four triangles are congruent. So I'm going to say 4 times parentheses. What is the area of a triangle? I'm going to say 1/2 base times height. However, well, actually, I'm going to put B and H for now, and we're going to change that in a little bit. Plus the other square. Now, the green square has sides of, what are the sides of the green square? C. We're almost there. We got to fix this up a little bit, then do some algebra. Now, just focus on one of the triangles. I'm going to stop this moving around business. Let's just look at one of the triangles. The base and height can be identified as which 2 letters? Remember, in a right triangle, it's the legs. Every one of these right triangles has the legs. What are they? Give me the letters, the length. A and B. So, in this shape, base and height are going to be A and B respectively. Doesn't matter which one's the base, which one's the height. That's how we find the area of a right triangle. So everyone should have that formula. Yes? Did you hit the right arrow key? Got it. Right. Now, I'm going to hit Command C and Command V because we're going to take this and we're going to work with it. We're going to modify this. How many of you don't remember how about more positive? Who remembers what a perfect square trinomial is? But algebra 1. Oh, 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 oh. All right. Now, I know you guys haven't done algebra in a while, so off on the side, and I'll do this in another color. I'll do this in orange. We're just going to review what a perfect square trinomial is. Now, I'm going to take a binomial, a plus b. When I'm squaring a plus b, that means a plus b times a plus b. Now, each of those is a binomial. It's the same binomial. And you all remember FOIL, first, outer, inner, last. So, when I multiply the first terms, the two first terms, the a and the a, what do I get? A squared. So write it down. You got a squared. This is good review because you're going to need this skill later on in the book anyway. Now the outer, and I'm going to skip over like this. I've got an a on the outside to the left, and on the right I've got a b. So outer times, or the outers, the product of the two outer is, what is this?
Oh, sorry.
What's that? That's an a. What's that? So the outer is ab. What's the inner? It's b times a, and since multiplication is commutative, I could just express that as ab. I'll just scoot this up a little bit. And finally, the last terms, I'm going to multiply the b times the b, and I get b squared. Now, if you write it this way, that may help remind you that in a perfect square trinomial, a plus b, that quantity squared is a squared. How many ab's do we have? 2. Plus 2ab plus b squared. There's 3 terms. So go ahead. Over here, we're going to fix that up. I'm going to say a squared plus 2ab plus b squared. Heavens to Murgatroyd, this is awesome. So the left side has been resolved. Let's look at the right side. What are 4, if I multiply 4 times 1/2, 4 halves are 2. Another way of saying that is half of 4 is 2. So I'm going to replace this with 2. I'm just going to do the arithmetic. Oh, it's getting good. We're almost there. What are we going to do with all the extra time? I don't know. Well, I know what Cody's going to do. He's going to do he's going to do the altitude to hypotenuse. So let's Command C, Command V. I'm going to cut and paste this. Now, just for dramatic effect, do you see what we're going to do from both sides? It starts with S and rhymes with abstraction. So exactly. Boom, shakalaka. Let's take that. What? Oh, yeah. You've got a 2ab on both sides of the equation. So go ahead and subtract it from the left side. And then subtract it from the right side. And heavens to Murgatroyds, what do you end up with? That's it. That is your proof. That is super cool. I mean, look at that diagram. Let's scoot back down there. You made this diagram, and you walked through all this, and we recorded this, so I think we'll post this on Nani Notes for anybody who missed it, and they'll get the live version. Yeah. So that is fantastic. Yeah, that's distracting. Let's do it like this. Oh, Nani. Hang on. I got danger. I think we can stop this recording.